Which expression is not a solution to the equation 2 to the t is equal to radical 10? So instead of us trying to figure out which is not a solution from the get-go, let's try to actually solve this equation using the methods that we know. And then from there, we can sort of logically conclude which of the answer choices doesn't match our way of thinking. So I'm going to start by rewriting on over here the original problem. And by observation, I can tell now the left and right hand side. I can't do this by hand where the left and right hand side will have the same base. So we're going to have to resort to using logarithms. And we can solve this in a couple of ways. We can solve this by using log of base 10 or solve this by using log of base 2. I want to solve this by using log of base 2 first because I see there in options 1 and 2 it involves expressions involving log base 2. So I want to do that first. So log base 2 of 2 to the t is equal to log base 2 of radical 10. I took the log base 2 both sides. The next thing is I want to apply the power rule. What does the power rule say? I'm going to quickly review what that is. I'm going to write it in red for all the rules that you need for this. And that is if I have log base a of b to the power of c, let's say, right? Then this is equivalent to c times log base a of b. The exponent inside, that is in the argument of the logarithm expression, that comes out in front and becomes a coefficient. This is the one feature that makes logarithms so versatile in solving unknown exponents, because it turns an exponent into a product. So I take this, okay, and I apply the power rule, and it becomes t log base 2 of 2 is equal to log base 2 of radical 10. And looking at this now, I have log base 2 of 2. So something else you should be aware of, and that is the identity, right? If I have log base a of a, this is actually equivalent to 1. And why is that the case? Well, that's because log base a of a, when I re-express this in exponential form, this is really the same thing as a to the first is equal to a. And if you're confused about why that's the case, maybe you should look over the conversion going from logarithmic form to exponential form, right? So let's say if I have log base a of b is equal to d, okay, then what happens is this gets rewritten as a to the power of d is equal to b. Anyway, so I want to apply the identity, right, which is t log base 2 of 2. Well, I'm sorry. Log base 2 of 2, that just simply becomes 1. And log base 2 of radical 10 is just what that is, right? So in other words, t is equal to log base 2 of radical 10. And looking at that, that's actually option 2. So option 2 is not good because that is a solution. We're looking for something that is not a solution. And then upon closer inspection here, t is also equivalent to log base 2 of 10 to the 1/2, right? Because radical 10 is the same thing as 10 to the power 1/2. And if I apply the power rule, again, I get 1/2 log base 2 of 10, and that would be option 1. And that's not good because that is, in fact, a solution. The next thing I'm going to do, and this one here is a little tricky, okay? Option 3. It doesn't really quite look like anything, right? It doesn't quite look like what I have here. So what I'm going to do with option 3 is, because a logarithm, I can re-express this by converting this into exponential form, and that's what I'm going to do. That's the logic I'm going to take. I have log base 4 of 10 is equal to t. If I rewrite option 3 in exponential form, I'll end up with 4 to the power of t is equal to 10. Looking at this rewrite, 4 to the power of t is equal to 10, I can then rewrite that and turn it into 2 to the power of 2t is equal to 10. And if I take both sides, raise it to the power of 1/2, what will become of this? This will be 2 to the power of 2t to the 1/2 is equal to 10 to the 1/2. And what will become of that? I'm going to end up with 2 to the power of t is equal to 10 to the 1/2, which is exactly what the original problem statement is. So that is not good. So option 3 is not good. Which leaves us with only option 4 that doesn't work. And again, just to test this out, why does option 4 not work? Well, we can certainly try to solve for t using a base 10, or we can, do something similar. Let's say if I have log base 10 of 4 is equal to t, if I perform the rewrite, I'll end up with 10 to the t is equal to 4, which is not the same as what we started with. I cannot manipulate this expression to make it look like, or this equation to look like the question that we started off with. And an alternative way of explaining why option 4 doesn't work also is we can solve this problem using log base 10. So if I have 2 to the 10 is equal to, let's say, radical 10, if I solve this by using log base 10, right, log base 10, 2 to the t is equal to log base 10 of radical 10. I'll end up with, on the right-hand side there, right, this is going to be log base 10 of 10 to the 1/2. Apply both the power rule and identity, I'll end up with 1/2 log base 10 of 10. I'll end up with just 1/2. And then on the left-hand side, apply just the power rule. I end up with t log base 10 of 2. So in other words, t will equal to log 1 over, so I'll end up with 1/2 times 1 over log base 10 of 2. This is what t really should be if we're using base 10. But again, option 4 doesn't look like that. So option 4 is the only one that's not the solution. I have to say, for a log and exponential problem, this is a challenging one.